All right. So you have decided, first of all, you have decided how many forces acting the charge 3 and their directions, and then use Coulomb's law to work out these force or forces one by one. But if you just tell people this force, so this force obviously is between 1 and 2. Do you agree?
Yeah.
In other words, this force contains the two parts. Can you see? If I just enunciate this force contains the two parts. The force 3, can use this one, which it contains the force between 1 and 3, and the force between 2 and 3. Do you agree? So the force must be the vector sum of these two forces. Now, the force you write down here is just the force between 1 and 2. Do we need this force? Do we have to work out the force between 1 and 2?
No.
No. The question is, what is the force? So what is the F force on the total force? Question. The force on charge Q, charge 3. 1 and 3 is 1 and 3 is you can use the same formula, right? Coulomb's law is the same.
My pen ran out of charge, but it's over 9.
Yeah, can we just can we show you, if you want to work out force 1 and 3, can we use the Coulomb's law in this formula first? Can you see? So what is the distance between these two? What is R in this case? That is between 1 and 3.
It's 9.
Yes, that's right. 1 and 3 is 9. Yes. So that is a K. Or do you know K? 9, sorry, square, right? 9 square. And Q1 is 0.5 square multiply negative, right? 0.7. Okay. Yeah. Do you know K? What is the K? The Coulomb constant. Do we know Coulomb constant? 9.9, right? 8.99 multiply 10 to power 9 in the international system. It's a huge number. Can you work out this force first? The force between 1 and 3. So the first term.
1 and 3 is equal to on a calculator?
No, the K. You can this is a constant you can use. This is called the Coulomb constant. There is a constant in the Coulomb law, and this is a constant in the international system, unit system.
It's 0.43.
Okay, 0.3. Yes, how about another force, which is also attract the charge 3? Yeah, you can keep the K there, and we can work out the K afterward. That's right, Q2, Q3. That's right. Yeah. It's a negative number. Yes, both are negative. So they're in the same direction, right? Toward the negative sign of the x-axis. Actually, you don't have to consider the sign when you calculate the magnitude. Doesn't matter. You can use the negative.
Yeah.
Oh, that is a large number, right? Are
Mm-hmm.
you sure? 0.0.
I think it's because 4 squared is smaller than 9 squared, so it's
4 squared is 16. That number should be much smaller than this number. Do you agree? Because the product of this.
Oh wait, I did times instead of divide. Yeah.
Yeah, you have divided by 16.
It is times 10 to the negative 3.
That's it. That's right. Yeah, negative 3. 10 to the negative 3. Yeah, probably so does this one. Did you divide 80? Did you divide 9 square?
Yeah.
Oh. Are you sure?
Divide. Oh, never mind.
Not yet. Not yet. Not yet.
It's negative 4.3 times 2 times 10 to the negative 3.
Yes. Yeah. 10 and 10. Okay. So finally, can we work out the total force on this particle 3? So when you just calculate because first you have to decide whether it's which direction of these two forces. If they are in the same direction, you can simply add them up, right? Although they are two vectors, but in this case, they are parallel. Yep, that's right. So you can just substitute these numbers that will give the force in Newton. It's pretty strong, right? Very strong. So that is how to use Coulomb's law in the simplest case between point charges. Do you want to more challenging question to apply Newton's Coulomb's law? Let's consider this situation. If you have this this time, we just consider the plane, XY plane, this x-axis, this y-axis, all right? So this time we have to use the coordinate y, x. So on the x-axis, we have two charge, and this one charge is the Q1, which is a positive. Another is the Q2, which is negative. And there's another charge on the y-axis. And actually the position just form. In this case, if this is a -2, I'm talking about the coordinate here. So this is, do we have to use a special triangle? Maybe we don't have to. Yeah, if you just consider another charge, charge 3, right? Charge 3 is a positive, So charge 3 is a positive. And how can we work out the force? The question 2, how can we work out the force acting on charge 3 if this distance, if this is so if this distance is, if this is 0, this -2 is a +2. And this coordinate will be 0 and say, let's do something simple. Can we go to 3? Can we go to 3 and this is 4. So 0 and 4. So this coordinate here, the position of Q3 is 0, 4. Now, question is, can we find this? So the question is, what is the force acting on charge 3? to find the force. To find the force. Can you say this is called electrostatic force? Electrostatic force on Q3. Okay, do you want to try? So this distance is in the centimeters. Okay, it's 3 centimeters. So these numbers are in 4 centimeters. So this is a.
Can you figure this out using the Pythagoras theorem?
Yes, of course. Yeah. So the distance, you got 2 distance, yes. Now you have decided whether these forces are attracting or repulsing. Have we decided?
Is Q positive or negative?
Well, Q first.
Is this positive or negative?
Q3 is a positive. Okay, Q3 is a positive. I probably will give a number as well so that you can calculate. Given Q1 equal to Q2, the amplitude is the quantity is the same. Equal to Q3 equal to 0.4 coulombs. Okay, but Q is a positive. You see, positive 0.4, and Q2 is a negative 0.4, and Q3 is a positive 4 coulombs. That is a condition. Why did you draw this attractive force between?
Oh, it's repulsing. They're repulsing each other.
Right. That's right. Then you have to extend that. Okay, that is along this direction. Can you see? Otherwise, because this time we have to work out the vector sum of 2 components. Yeah, both distance are 5 centimeters. Can we use the colored arrow to indicate the 2 forces you are calculating? One is that one, can you see?
Yeah.
Another is attraction, isn't it? Another is traction, can you see? They are same in magnitude.
So the total force on Q3 would be 0.
No, you can. This is a vector sum, not the, is different from previous question. So do you remember the vector sum? If you have 2 vector, we discussed it before. Do you remember? In mathematics, if you have 2 vector, vector 1 and vector 2, and the sum would be graphically would be the diagonal of this parallelogram. You cannot add them up. They are not in the same direction anymore. So the sum of these 2, this will be the sum. Do you remember? We discussed this before when we studied the vector in mathematics. Can you see? So if this is force 1 and this force 2, so this one will be F1 vector sum plus F2. Can you see? So this is not, you cannot use this formula anymore. They are not scalars, they are vectors. So when you're dealing with force, you have to use a vector. Okay?
Yeah.
Alternatively, you can form the triangle. Can you see? If
Mhm.
you can also move this F2 to other side. Can you see?
Mhm.
Can you see? This also gives the sum of two forces.
Yeah.
So you decide how to work out this force. Yeah, it is also true. When you apply the Newton's second law, you cannot add these two forces by numbers. You have to consider their projections, or you have to consider the vector sum. Now, if you can either use this triangle. You can use a triangle to work out their sum. Can you see? This F1. Can you see?
Mhm.
F1, then you have to decide this is 60 degree, and another force is this one. So this also the, you see that is also.
So if I know that this is F1 and this is F2.
That's magnitude. Yes, that's the magnitude, not a direct. You have to find the correct. You consider the direction. Can you see? This is a sum. Can you see?
Mhm.
This is a sum. So this will be the sum of two vector. So this is F1 plus F2 vector sum. Which diagram do you want to use? You can either use this triangle or you can use this projection. Can you see?
Mhm.
Or you can just work. Yeah.
I think I'll use this one.
Yep. So this
But
F1.
this is how I figure out the angle, right?
Yes, you can work out this angle easily.
It's tan over y over x. Tan y over x.
Where is your theta?
Oh.
Which angle are you refer? Do you
The
refer?
angle is this one.
So, the angle between these two, right?
Yeah.
Okay. Well, what is that angle between these two?
So theta 1 equals tan x.
XY. Where is your XY? You mean here? XY here? Where is XY?
Yeah.
You see, you have studied. You have studied vector in mathematics, but now you have to apply this vector sum to solve this physical problem. We need to find the sum of two vectors whose amplitude are the same in this case, but direction is different. So that is why I suggest to draw this diagram in the first place. Because from here, we know this, and can we work out this angle? We should be able to work out this angle, right? This angle, if we just go up, draw the parallel, can parallel straight, and this angle should be also the theta. Do you agree?
Yeah.
So this theta is more important. And this angle is just 2 theta, isn't it? The angle you are talking about is just 2 theta, isn't it? Right?
Yeah. So inverse tan y over x.
So what is x? What is the y?
Y.
You mean that the opposite, right? Opposite. 4/3, right? Yeah.
Yeah.
So you can work out this angle, right? Now with this angle, what can you do?
Then you know the vector projection?
Yes, do you know we talked about the matrix form of vector. If we use a matrix form, so F1, if you use a matrix notation, so F1 can be written as their amplitude. Their amplitude is F1. Can you see? F1 X components. Can you see? That will be equal to F1 cosine theta, which is this your theta, all right? And the Y component will be F1 sine theta. Do you agree?
Yeah.
Similarly, how about F2? If we use a matrix to denote this vector,
it's F2 cos theta F.
Yeah, the same thing, right? But be careful. The Y is negative. Can you see? This you have to put a negative Y here. Can you see? You have to put a negative sign here. F2 sine theta. Can you follow me?
Yeah.
Okay. So do you remember the vector sum can be worked out by just use their components in matrix form? Do you remember that? I think we discussed this before. They're all the same, right? Because these numbers are the same. So this actually F1 equal to F2. It's a constant, right? It's a constant. So all these F are the same. How can we find the total force? This is the total force. Yeah, cosine plus cosine, yes. So what is a 2? Where does this 2 come from?
Because you add both of these up.
Ah, the 2 plus, yes. But how about sine? Why is negative? Why is it positive?
Oh. And then it's just 2 cos theta, isn't it?
Yes. Yes. Can we use before you go, can we you have used a matrix form. Can we use matrix form? So that is can we write it down here? Can we so this is F cosine theta plus F cosine theta, right? That is F sine theta. Take F sine theta. Therefore, we can get another matrix, which is a 2F cosine theta 0. Can you follow me?
Yes.
Obviously, the sum of this force must be along the parallel direction. Do you agree? The total force. That's not surprising. Therefore, they have no Y components. Can you see? That is why there's no Y components. So this is how to work out the force of 2 components. Right?
Yeah.
Can you work out the result now? This is a little bit crowded. Can I just go to next page? You just independently try it again. Can you just very quickly draw this diagram? Otherwise, this is a relatively challenging question. So if I just redraw this very quickly, so you got the one is symmetrical about the y-axis, and this is the third one. So this is so this coordinate. So this coordinate is 0, 4, and this coordinate is -2, 0. And this one is +0, this axis, y-axis. So this Q1, can you see? Q2 and Q3. Of course, I can help you to draw this triangle. The distance is here. Now, can you this time work out the force between this on the direction of the force? So this is a positive. This charge is a positive. This is a negative, and this is positive. So this is positive Q3. Can you work out the force by the arrow? Can we use arrow? This is Q3. Yes, that is one force. There's a tool you can use. Can you see? Another one, another in the spot. Go to the drawer. If you go to drawer, if you go
like that.
Now this probably use different software. If you go to draw, can you draw this arrow in your from the zoom?
No, I can only draw these ones.
That is a stamp, I think.
That's the only arrows I can do.
Oh, okay. You probably use different software. Well, then you can use straight line. You can just draw a straight line then. Yeah. It looks complicated now. Can I just do that for you, right? I can draw this two force with this. Okay, this one force. I probably use the red color. This is repulsive force. Okay, we're only interested to know. Yeah, if you have to, these two forces must equal in their amplitude, right?
Yeah.
So the another force is go along this direction. Okay, so they must be equal in their amplitude. Okay, in this case, can you graphically indicate the sum of these two forces and then calculate them? So this is F1, you see, F2. That's right. To be exact, it must be diagonal. Can you see?
Yeah.
Okay. Can you work out them by yourself? Either use matrix or you can use this triangle. This is total, right? I talk about total force. Yes, it's total.
Yeah.
You have to be careful. This is vector. You have to use a vector. That's right. Negative, yes, that's right. So they are all the same, right? F1 equal to F2, they're all the same. It's total. You have continuous metric. If you do, this is 0. They have used continue. Don't forget, a vector can be written as its two components. All right. If you use a matrix form, you have to always use matrix form. Can you see? That's how to use two component to represent the components. Yes. So you got these two components, right? So what is so that will give you the can you yes, can you calculate the theta? You know the theta now?
Oh.
Yeah. There's 3, there's 4, there's 5. Can you also use a sine or cosine rule to solve this problem? Without this is matrix form. So this method is use a matrix, okay? Matrix method. Can we use a triangle formula? Can you see this is a triangle? We have two sides given and one angle is given. Can you able to find the size of a third angle, a third side?
Yes.
That's right, because these two sides are equal. Can you see? These two sides are equal. So this size to be determined, but this angle is also given.
Yeah.
Okay. You can.
So since we know that one side is,
yeah, I just wondering if you can use the triangle formula without use matrix.
I
should,
don't think so, because we don't have the length of this side.
Which side? We know F1, we know this side is F1, we know these two sides are equal actually.
Oh.
This
then we can, yeah.
This angle is 50 something, 50 degrees something, right? 51 or 57. Sine row or cosine row, I think. Cosine row, isn't it?
Yeah.
Can you write?
I think it's a sine rule, which is the A over sine A equals B.
Yeah, you can use sine row as well because we know both sides and angle.
Yeah.
Right? This is isosceles, right? These triangles are isosceles. Okay, that's right. Yeah, you can use sine row. Yes.
Yeah.
But do we know this angle, the third one?
If we find this angle, then we can.
Yeah, can we call it angle alpha, right? Can we go, so what is alpha?
Alpha equals.
Both are theta, right? That's right. Pi take 2 theta, yes.
Do we know the charges of these forces?
You have calculated the two forces, right?
I haven't calculated the magnitude of them.
You did. Can you see?
Oh, that's from before?
Yeah, that is force.
Okay.
So that is a magnitude. Can you see?
Yeah.
So these two numbers are the magnitude. They are identical, but they have size. You have to fix the sign. They have different direction. The magnitude are the same. They're all 6.4 multiply 10 to the power 3. Can you see? So in this case, we can use sine rule. Can you see? And use the sine rule, right? So this is your first need to know. So according to sine rule, so what is unknown?
6.
Yes, sine. That's right. You can use sine rule. Yeah, can you calculate this one to compare with your result? So you got two formula method, right? From the first formula, the F total along the x directions is equal to 2 multiply the F multiply cosine theta. And multiply the K, right? Another, you had the Coulomb constant. You have multiply K, the Coulomb constant. Yeah. Yes. Okay. Can you compare with this result previously obtained by use the matrix method? Are they identical?
Yes, they are.
Wow, that's great. That's great. Yeah. So finally, you have to convert this. Can you substitute this K? Can you substitute this value? You have this is 8.99 multiply 10 to the power 9. Yes, 8.9. So that is a number. This is a K constant, a Coulomb constant.
That's the total force.
Yeah, you can use you can use scientific notation, but just use probably 2 decimal places. Multiply 10 to the power how many? 0? 9?
1, 2, 3, 5, 6, 7.
7. What is the unit for force?
Newton.
Yes, it's huge, isn't it? The force is huge.
Yeah.
So that is actually the forces between different atoms, right? And I think that is the second question is a little bit challenging. You have to consider the direction. Direction. I think that's all about the Coulomb's law. Do you have any other question? Have you studied this formula that the force, electrostatic force, can be written as a Q multiply E? Have you studied this formula before?
Yes, I think so.
Yeah, this is very close. This is very close. And this in this case, E is called electrical field, right? Electrical field. And this is a charge. This is electrical charge, right? Electrical charge. After you learn how to use the Coulomb's law, you are going to start this formula. Compare with the Coulomb law, the force is equal to K multiply Q. Can we just use a capital Q and Q to indicate a 2-point charge, right? So this is a Coulomb's law, right? So how can we obtain the first formula from the Coulomb's law? So in this case, can we just draw the diagram? So basically, we are trying to work out this is Q. Another charge is called lowercase q, right? So Coulomb's law allows you to work out the force between these two point charge. If the distance is r, that is Coulomb's law. Without using the electrical field, this idea, can you see? E is for electric field. You know, B is what? B is magnetic field, right? We discussed not of Lenz's law, is a magnetic field, right?
Yeah.
And E is electrical field. Okay, that is the first time we introduced the electrical field. So the field is just the property of the interaction between the two charge, right? But the field is not visible. We still can specify the charge at a different space. So here we have introduced something very useful, but not very tangible idea called the field. Can you see? Electrical field, magnetic field. Can you see the field, right?
Yeah.
So what is a field? After all, what is a field in physics, in electromagnetism? What do you think?
Electricity.
No. You're talking about electric field, yes? Not quite. Yeah, it's related to electricity, but actually, if I just rewrite this equation, you will know what is a field. Can you see? can we just do some variation from equation 2? Can we just rewrite with this formula? So F can be written as, can we put the Q, little q in front, all right? I just rewrite it, and this became K multiply capital Q, can you see?
Yeah.
And divided by R squared. Nothing changed, do you agree? And then we introduce, we just define that E equal to KQ divided by R squared is electrical field associated with capital Q. So the field is just the space property of charge, right? This is our third equation. Can you see? This is our third equation. This is 3. This is 4. Okay. If we do some substitution, can we substitute equation 4 into equation 3? What can we obtain?
You get QE.
Yes. Can you write it down? You can write. What is F? Yes. That is our equation 1, isn't it?
Yeah.
So from here you can see the force. So from this one, so that this equation tell us the electrostatic force can be written as the product of charge, electrical charge, Q, and wait a moment, and the electrical field, Can you see? This is different from Coulomb's law. Can you see? The Coulomb's law says that the charge, the force can be written as a product of the two charge divided by their distance square, multiply a constant K, right?
Yeah.
But this formula say the force can also written as the product of the charge to be studied, okay? If you want to know the force on any charge, then we can use this charge and multiply the electrical field generated by other electrical charge. Does that make sense? So that is very useful idea, can you see? So this formula is for electrical field of point charge. So this formula, which is also a vector. So electrical field is also a vector, like a force. They got a direction, and they got the they also have the amplitude. So in other words, these formulas say if we know the if you know this is the same situation, can we just draw these two scenario? This is one scenario, okay? Alternatively, you can say that we know the electrical field That is a bit abstract now. Can you see? At this point, we know the electrical field. Okay, although we don't know which charge generated for this charge, the field, we don't know, right?
Mm-hmm.
Can we call this vector the E, right?
Yeah.
If that's right, this is in the space. If we don't know this, we don't know what's the origin. Of course, in this case, this charge is generated by capital Q, right? If you put the charge with Q, then we can work out the force. Can you see? Can you use different color? Can you see? We can work out the force. Okay. So this force is equal to Q multiply E. That's all, right? Well, in this case, the force is this force according to Coulomb's law. You have to use the Coulomb's law, right? This force. Can you see that? This force, you have used F equal to K Q, capital Q R squared, all right? But in the second case, we don't care the distance. We don't care which charge generates this electrical field. Just use the product, that's all. Can you follow me? Or confused? So that is very clever. You know, in physics, sometimes you say, because you know what, if you use the Coulomb's law, the situation can be very complicated. For example, if you have many charge, right? Can you imagine there are many charge, like a molecule, right? So this is Q1, Q2, and Q3, and any. But we are only if we are only interested to know the fundamental force acting on this charge Q, right? If you use Coulomb's law, you have worked out this. We have tried before. You have worked out this interaction, right? You got the force or positive, negative, and you can work out the pair another force. Can you see? And also is you have to choose whether it's an attraction or not. Okay. So you have to the force. You have to generate this force. The total force will be the vector sum of all pair of forces, right? However, if we don't know, if we just pretend we don't know this, we don't know them at all, but we know the field, electrical field. Can you see this time? If you know the electrical field this time, for example, this is a total field, all right?
Yeah.
This is a total field. That is an electric generated by all these. This is a total field. This is a field generated each of this remote charge, right? And then if we ask the force, what can we do? If we ask what is the force, we don't have to do this sigma. We only need to find this product. Can you see that? Think about it, all right?
Yeah.
That is a variation, like music, right? You got a theme, this variation. So because as we have encountered today, if you have considered 3 or more charges, we have used Coulomb's law again and again and again, right? If you got too many charges here, that would be very tedious, all right? So that is why physicists introduce, say, let's consider the electrical field, right? If we know the electrical field, we don't have to calculate the force one by one, right?
Yeah.
Okay, we'll stop here. Anyway, of course, you can argue that how could you know this electrical field in the first place? Well, you can either calculate that one by one, or you can measure that electrical field. Okay.
Yeah.
All right, we'll stop here and see you next time.
Okay, I'll see you next week.
Okay, prepare some questions we can discuss. Goodbye.
Okay. Thank you.
It's safe and stop.